In lesson 3.5, we are learning about addition, subtraction, and scalar multiplication of matrices. All right, so these operations are a lot easier than multiplying matrices. With addition and subtraction, you just add or subtract the numbers in the corresponding locations. So for this first one, 5 and 4 are in the same location of their matrices. So I get 9, and then -4, and this -4 and that 5 are in the same spot. Add those together, we get 1. All right, number 2 is the same thing except with a 2 by 2 and subtraction. All right, so 8 minus 0 is 8. 3 minus a -7 is 3 plus 7. -1 minus 6 is -7, and -1 minus 2 is -3. All right, you can only subtract or add matrices if they are the same dimensions. And let me quickly review how to measure the dimensions. So you count down first. So 1 row going down, and then 3 columns. This is a 1 by 3. This is a 3 by 1. And since those aren't the same dimensions, it is not possible to add these together. Now what you'll learn soon is that you could multiply those together. A 1 by 3 and a 3 by 1 can multiply together. All right, number 4, they are the same size, so -5 plus 9 is 14. Sorry, that was +5 plus 9 is 14. -1 plus 9 is 8. 2 plus 2 is 4. 1 plus 4 is 5. 6 plus 8 is 14. And -6 plus 4 is -2. All right, number 5, this is not multiplying two matrices together. It's multiplying one matrix by a number outside. So that is called a scalar. So it's kind of like we're making a scale model of the matrix inside the brackets. So everything inside is going to get multiplied by 3. 27, 12, -9. All right, and now number 6, we have subtraction, and one of the matrices is getting multiplied by a scalar. All right, so I'll do this in 2 steps. You have 2 options here. You can either distribute a -4 and change it to addition, or you can keep it subtraction and distribute a +4. So I guess I'll just keep it subtraction. And now I'm multiplying +4 inside. So 6 minus 16 is -10. -3 minus 28 is -31. All right, 7 through 12. Same thing, but they tell you what the matrices are up top, and then they make you do these operations based on their names, which are a capital letter. All right, so if it helps you, you can just rewrite the matrix. So this is matrix A, and I'm going to subtract matrix B from that. All right. 4 minus -2 is 6. -1 minus 4 is -5. 0 minus 5 is also -5. -3 minus 1 is -4. 6 minus 0 is 6. 2 minus 9 is -7. now we're doing A minus C, so just rewriting it. There's A minus and C. All right, so let me write a little smaller down here. 4 minus 10 is negative 6. Negative 1 minus a negative 8 becomes negative 1 plus 8. 0 minus 6 is negative 6. Negative 3 minus negative 6, that's another double negative. So that becomes negative 3 plus 6, which is 3. 6 minus a negative 4. 6 plus 4 is 10, and 2 minus 20 is negative 18. All right, number 9, we just have to take everything in here and multiply by negative 3. So I think I'm just going to go straight to the answer. I'm going to multiply the first item by negative 3. I get 6, then negative 12, then negative 15. And negative 3, 0, and negative 27. All right, on number 10, we have a scalar of matrix B. Matrix B gets multiplied by 4, and then we have to subtract A from that. All right, so I'm going to go ahead and just multiply matrix B by 4 right now. So I get negative 8. 16, 20, 4, 0, 36, minus, and let me rewrite matrix A. All right, and now subtracting, I get negative 8 minus 4 is negative 12. 16 plus 1 is 17. 20 minus 0 is 20. 4 plus 3 is 7. 0 minus 6. 36 minus 2. All right, so again, to save room, let's just go ahead and multiply matrix B by negative 2 to start. So I get positive 4, negative 8, negative 10, negative 2, 0, and negative 18. All right. I think I'm going to do this part a little differently. So earlier when we had subtraction and a scalar, what did I do? I distributed the positive and kept it subtraction. So let's try this one a little differently. I'm going to change it to addition, and I'm going to distribute the negative 3 to C. All right, so if I distribute negative 3 to C, I get negative 30, 24, negative 18, positive 18, positive 12, and negative 60. And so now that I have distributed the negative, it is now an addition problem because the negative went inside that C matrix. All right, and now I'm just going to add the corresponding locations. Negative 26, 16, negative 28, 16, 12, and negative 78. All right, for number 12, I'm going to rewrite matrix A. And and I'm going to multiply everything in matrix C by 0.5. So I'm just going to divide everything by 2. That's the same thing as multiplying by 0.5. All right, so we get 5, negative 4, 3, negative 3, negative 2, 10. So now I add the corresponding locations. 4 plus 5 is 9. Negative 1 plus negative 4 is negative 5. 0 plus 3 is 3. Negative 3 plus negative 3 is negative 6. 6 minus 2 is 4. And 2 plus 10 is 12. On the back, they are asking us to write matrices to represent the table shown. The directions say to use the number of new businesses and the loan amounts. All right, so 2 matrices, one for women and one for men. So for women, I'm just gonna copy the numbers I see right above. They do not tell us to include the year. All right, and then for men, the matrix would be 36, 864,000, 32, 672,000, 28, and 562,000. All right, and then for part B, we are asked to add these together. I'm just gonna go ahead and I'm just gonna put a plus right here and add the corresponding spots. All right, so I think I'll start with just doing the left column. 27 plus 36 is 63. 41 plus 32 is 73. And 35 plus 28 is 63. All right, let's add those dollar amounts together now. 567,000 plus 864,000 is 1,431,000. Right, 902,000 plus 672,000 is 1,574,000. And the last two numbers, 777,000 and 562,000 make 1,339,000. And so this matrix shows how many loans there were total in each of the 3 years and how much their combined values were. All right, that is it for 3.5.